Hello guys, welcome. So today we are just going to recap some of our important uh, concepts which we have already discussed. So this is a recap. Uh, First of all, you can remember what is capital D. It is a set consisting of xi and yi, and there are suppose n number of datas. So yeah, this we also call as training set, right? So this set is known as training set, where this y consist belongs to a set consisting of an integer from 1 to c, and c is total number of classes. And if this is so, then we actually called it as classification. But if yi is a real number, then we uh, call it as a regression, right? We also discussed about our model. uh, okay, this model is trying to predict y based on the the test input and training data set. So this D I have already said is training data set, and this vector x is test input. So suppose uh, the probability of y after we know the test data set and uh, the training data set is like this. Okay, so yeah, these are suppose class 1, class 2, class 3, class 4, 1, 2, 3, 4, 5, 6, 7. So there are 7 classes, and uh, these are the probabilities, right? So our model is trying to predict this graph, and suppose this is y hat. This entire thing is classes, and this y hat have the maximum value of the probability. So based on our map estimate, we can assign uh, this test point as this class. So the class will be C2, right? Or C3. C1 is this, C2 is this, and this is C3. Okay. So uh, what is map? Map is maximum or posteriori, or we can say it is the most probable level, right? And So I have also said that there are unsupervised learning and supervised learning. So unsupervised learning is also known by knowledge discovery, right? So there is no level already provided in the training set, and we only need to uh, so uh, in unsupervised learning, it is also known by knowledge discovery, and the model is of form. This is P, this is xi vector, and this is the model parameter. Okay, so this xi is nothing but vector of features, right? And okay, so this is unsupervised because there is no level, right? There is no y. So next we have discussed about parametric model. And what is this? Uh, we said that there are fixed number of parameters of a model, then it is known as parametric model. And if the parameters, if total number of parameters increases with respect to increase in dataset, suppose training dataset is increasing and this is resulting in increase in parameters of the model, then we will say it is not parametric, right? So yeah, then we have discussed about linear regression, right? So what is this? The word linear means there is some linear relationship between the input vector x and output response y, right? And this relationship is given by this form. Okay, so this is the weight, this is x input, and this is some error. So what I said, that suppose there are some data points and we are trying to fit a curve. So this curve equation is given by this one, which is a linear relationship with respect to x, and the error between this, the curve, and the data point. So I mean this is given by epsilon or e, right? uh, so in most of the time this error follows some type of distribution, like the Gaussian distribution. So if this error is Gaussian distribution, this is fixed, then entire y will be following the Gaussian distribution, right? With certain mean and uh, variance. So if this is zero mean, then the mean of y will be, this is 0, then this value, right? So what I am saying, p of y given x and the parameter of the model is nothing but y mu of x square of x, right? Where this is mu is what? Weight and x, and this is fixed. So we have assumed that the um, error, right, this variance will be fixed, and which is equals to sigma square. Then we discuss about uh, linear regression. Okay. By the way, the output of this is not a fixed or discrete number, right? It is a real number output. Okay. But here, although the word is regression is associated with this term, but this is not a regression. So it is represented by y, x, w, which is equal to Bernoulli distribution, y sigmoid function of w2 x x. Okay. Uh, and you know sigmoid function we use to squeeze the term from 0 to 1. So it is 1 plus e to the power minus x, right? So when x is positive infinity, so this term becomes 1 plus e to the minus infinite, which is equals to 1 plus 1 by 0, which is equals to 1. And when x is minus infinite, then 1 by 1 plus e to the power minus infinite, that is equals to 1 by 1 plus e to the power infinite, that is equals to, this term is infinite, 1 by infinite equals to 0, right? So that's why we are using sigmoid function, so that uh, this entire term can be between 0 to 1, so that we can assign, suppose there are some test points, okay, and this is suppose 0 and this is 1, this is the levels, right? So and there are some overlappings, right? And we want to find whether this belongs to this class 1 or this class 0, right? So this is uh, done using linear regression. Yeah. Then we also said that just by knowing the training accuracy, we cannot say that our model is really accurate or not. What I am saying, that if the training accuracy is high, suppose 90% or suppose 100%, so our new model, suppose our model is now able to set. So we have set all the parameters of this model in such a way that all our training data is predicted by this model accurately. But even if we have set this parameter to detect all the training set, it does not mean that it will behave properly with the real world data, or uh, we don't know how the model will behave with test dataset. Okay, so even if it is 100% accurate on training dataset, because it have already set its parameter, so it is now producing 100% result. But new test dataset may not be predicted accurately, so this is known as overfitting, right? So to avoid this overfitting, what we have done, we have created one validation dataset. Okay, and what is this validation dataset? This is a dataset. Suppose this was the entire training set. Okay, so what we have done, we have kept certain percentage, suppose 20 percentage of training data set, and used, and this 80% data is used to set the parameter of the model, and then this 20% data set is used to test the model whether the model is performing better or not. Suppose this is for parameter 1, right? And suppose it is giving some accuracy on this 20% data set, maybe 60%. Then again we have changed the parameter by theta 2, and we have tested some other 80% data, right? And we have trained the model again using this 80% data, and then we have tested with another 20% data, and suppose this time the accuracy becomes 65%. Suppose we do it again. Okay, and this time the accuracy is 50%. So, and so on. So we will pick, or we will save this parameter, this model parameter. Okay, so that it can uh, give the maximum accuracy, right? Yeah, we have also discussed about mutual information mission, right, which is also known as MI. So uh, so what it actually mean is that we have a data set probability distribution, right? So we want to know how this x and y are related. So knowing the value of x, whether it is possible to guess anything about y. So this is given by mi, that is mutual information, and it is like KL of p of xy and p of x, p of y, right? So this is nothing but p of xy, right? And this is log base 2 p of xy, p of x, p of y, for all x, for all y. Right. So which is also equals to entropy of x minus hx hx given y, right? Okay, and this is known as conditional entropy, whereas h of x and y is nothing but uh, p of x, h, y, all the x's, for all x, right? Finally, we have discussed something about prior probability, and this is given by p of x, and posterior probability p of x given y, right? And what is our MLE? This is maximum likelihood estimate. So whenever the data sets D, size of D is increasing, right, or getting larger and larger, then we can guess about our H hypothesis as that H which have maximum likelihood. Okay, so P of D given H, wherever this is maximum, and we have already said what is this, 1 by size of H to the power si size of the dataset. Okay, so wherever the likelihood is maximum, that is the correct hypothesis. Okay, that's all for review 1. Maybe I will be giving some more details in review 2. Thank you.